This title is so appropriate. I'm glad I picked it. I didn't know this was going to happen. So yeah, who am I? I'm the XML guy. Like everyone just kind of knows me as that. Author of Squirrel, that's xQuery 3.1. Language implemented on the beam, like transpiling down to beam. Also done Yakety Sax, woo, okay. And HTML URL, woo. All right. There is exactly one user for both of those. Yeah. And I'm not going to read that because I don't really have time, but it is kind of funny. So I'm here talking about Flyin and Priceline, which we saw the Priceline blue for like a long time. Flyin was a company, so based in Berlin, worked in flights, hooking up flight APIs for airlines to sell direct content there. Used Elixir, Google Cloud, Kubernetes, and yeah, had our homegrown DevOps right there. That's good. And yeah, a little bit about Priceline. It's an online travel agency headquartered in the US. It's part of Booking Holdings, a few of these brands that people know, because Priceline is probably an unknown to people in Europe. Booking.com, Kayak. Yeah. I'm not going to read that, but yeah, Priceline, 1997. Had kind of a neat thing, selling tickets for flights and hotel rooms, and you name the price you want to pay, and it was kind of last-minute stuff to fill up the planes and the hotels. That was kind of an interesting thing for 1997. Yeah, and the company's still around. It didn't bust in the bubble. And a little bit more about it, heavily using Java and TypeScript, but also Google Clouds, Kubernetes, and it's based, as you can see, through the US, Canada, and India. And fast forward to that part. This was about all the news you would have seen about the acquisition. Last line there says, terms of the deal have not been disclosed. So cool, we're part of Priceline. And Priceline now uses Elixir and a little bit of Rust. Yeah, they knew what they were getting into, right? It's not this. There are these stories out there about how the beam like snuck into companies, right? Like it happened on accident, and people are running airline like, what? We are? They didn't know that. Well, here it wasn't the case. It was a decision. So yeah, we're a long time. So we took our thing. We took what we were doing. We brought it into Priceline. Now that was a long journey where we were taking our traffic slowly live, like the traffic we would have had, 1%, 2%, 5%, things like that. During that time, we were really focused on getting all the bugs out, getting all the errors out, because it was kind of a new. We went from a version 4 of our platform to V5, right? It kind of changed that. But I would say it went well. During that time, we were able to kind of make friends, build different applications, interesting stuff. And we made a few discoveries on the way. So first off, XML handling is painfully slow. Like you'll have like 10 megabytes of XML, you got to go through it, and you need to do this kind of live. Like there's a person saying, I want to know all the flights going from these two airports. Well, it can be a big payload. Now doing that in pure Elixir, even if you're streaming it, it's going to be slow. So yeah, let's do it in Rust. The beam is resilient. Actually, I don't even need to go over those slides because everyone should know that. And but we did have a few issues with Kubernetes, like some learnings from that, moving from one machine type to another. Yeah, that noisy neighbor might be us. And it kind of was for a little bit. So yeah, XML. It can take like a second a megabyte to parse and transform the way we're doing it. So what do? using Rustler, make a NIF that tokenizes, then stores the data structure of the XML. And then make a bunch of accessor functions to go in there and pull the data out. And then because that would be kind of clunky to use and it can be error prone, build a DSL over that. That's just nice to read, right? And now we are lightning fast with XML. This is what it looks like. So what you see is what you get. Layout, so it's a function. You pass it the place you're at in the XML, and it will then extract these things. So here you've got text. These are going to be strings. But then there's a little more complex stuff, like if you want to nest these things. And other functions like int, where you could parse that as an integer. There's decimal, a few other ones. This kind of grew as time went on. But I liked it. That's pretty. I like it. You know, it's prettier than the other stuff you would do with XML. Hello. And this is kind of what it looked like for speed, but also CPU when we took it live. It was actually an interesting takeaway that the CPU changed so much by doing it this way, by using Rust. And then just using less slices, less time, less memory. It was really a neat exercise. So yeah, the beam is resilient. I'll blaze through this too. But we were setting up a service that essentially reads JSON things and serves them. It patches in that, patches a few values inside. Won't go into too much more about what the application does, but there was a Java service running. We were setting up Elixir one right next to it. We're going to do a phase rollout. But then we want to test that. And normally, if you want to stress test the DB, you just do it, right? But here I was like, I want to see what the beam can do. Can we scale down the app completely and just crank it on at peak? I want to see it. I want to see it explode or not, right? And yeah, then grab the popcorn. Thank you, ChatGPT. And it kind of looked like this. Like, we had very low pod count. Boatload of traffic comes in at once. We had the sessions were backing up a little bit, which was fine. App scaled. Connections went down. It was just normal. It was running within like 50 seconds. Everything normalized. So like, that was fun to see. And then the other people in the company are used to maybe Java or Python even, whatever they're using, had never seen anything like that. Like most apps would go into a back-off loop, they would just crash. And that didn't happen here, so everyone's like, wow, maybe we could use that for more stuff. It's just really neat. And now Kubernetes is fun. We were on some 4 CPU nodes, and we were migrating to 64, thinking, cool, we've got some room there. And yeah, process, how are we going to do it? Copy, paste, done. Let's go. Well, we had our CPU request set to 2, which when you're on a 4 CPU node, it's not going to do much. We just had little apps on the side of it. So it didn't matter if they got stepped on. No limit set. But then every so often, we're like, what is going on? There's a noisy neighbor. Something is slowing down. Something is wrong on that pod, but not the other ones. It's really odd. Well, we had 64 schedulers on 2 CPU. That sucks. So those flags have meanings. It's really good to set them to something that makes sense. Yeah. So we got to share the joy of the beam with people just by showing it what it could do, but also by expanding our team. We were this small startup in Berlin. But we had a team of Java engineers cross-trained into Elixir. And yeah, special thanks, Croxio. I guess he's talking about this. But that was neat because we were in 2 time zones now. So it kind of changed the entire dynamic. We had people online at different times. We could do on-call rotation, things like that, just being in two time zones. And at the time, too, we were learning into the company standards, the Java standards that were in existence already and had been for years, and learning into it, but we didn't really do anything about it at the time. We're like, no, we're different, right? We're running on the beam. We'll just do things differently. But all in all, it was kind of exciting. Like the Java developers that got trained over were extremely happy. They were just very happy. Things that would normally take a day took 10 minutes to do, like code changes. Like this was something that, mind blown. So that was kind of neat. And we also got to share the joy in the way we work, at least how we view things we're doing, right? Typical in a Java world where everyone's using the same code is you have a shared lib that has you have your jar that says this is the schema, this is how the data looks. Everyone shares that code, plugs it in, things just work. Well, now you've got another language in there. We can't just plug a jar in. That's not going to work. So we had to push towards schemas. A few other things we did using VCR, right? That was kind of a new thing, like, oh, wow, that's a neat idea. Just kind of bringing these ideas in of the way we do things. So that was, I think, a win there, where we got to share a lot of stuff. Why does it keep bouncing back? Something is stealing my, there we go. But yeah, it goes both ways. We didn't know everything, right? So there's the standard way of working that everyone had been working in, just kind of the Java standards, and everyone knew what they were talking about, and we didn't know what that meant, so there was a lot of learning on our side as an Elixir team. Things like, typical to Spring Boot, right? Map diagnostic context. I'm like, what is that? MDC, what does this even mean? And well, it's metadata. It's like logger metadata. That's all it is. So learning these things, changing our logger out to do structured logging to look identical to a Java app, so that people's dashboards all work, logging dashboards, whatever. Been a lot of other work that way. Going through the libs, they're there in existence. I mean, the Kafka stuff, yeah, but there's a typical setup that the entire company uses, so we have to pull it in. Yeah, different authentication methods that we had to learn into, A/B testing frameworks. So all these things had to be built out, at least the Beam version of them. Yeah, so there's been a lot of work in that direction. And yeah, so that title was more of a clickbait thing. We weren't just there, right? Like, we are there. We've been accepted into the team. We're a language that's used. Yeah. Yeah. And no Q&A.